Are you like me and you never could quite figure out how to solve the Rubik's Cube? Well, I found the fix. This is the 3D printed Rubik's Cube solving robot from Otvinta. This was a featured project on Thingiverse and I just had to build one. It has a ton of 3D printed parts, 8 servos and a pulu controller to move it all around, and a webcam to recognize the colors of the cube so it can solve it. You can run it off your PC or you can run it off a Raspberry Pi. This video is going to be pretty long because we're actually going to build this thing and get it set up in solving cubes. If you want to just see it solve the cube, here's the video of that now. Now, everyone that wants to stick around and build this thing, let's get started. And here's all the printed parts you'll need. 4 arms, 4 sliders, 4 pinions, 4 racks, 8 corners, 4 grippers, 2 legs, 4 nuts, 2 long bolts, 2 short bolts. You'll need a total of 8 rods, either long or short or a mix of both depending on what camera you use. 4 half-1 clamps and 4 half-2 clamps. One has a spot for the bolt to go. A camera holder and a camera cover. And here are all the non-printed parts. 4 DS3218 servos with the accessory kit. 4 servo extensions, 4 HS311 servo motors with their accessory kits, a Raspberry Pi, but you can also use a PC, a pulu servo controller, 12-channel, an inexpensive webcam with 6 LEDs on the front. You can either use 12 or 5 megapixel. This one is a 12. 6-volt 3-amp DC power adapter, and some connectors so we can connect it up to the pulu board. Around 100 M3 12mm screws, about 40 M3 nuts, and about 10 2mm wood screws about 8mm long. And last but not least, the puzzle toy that haunted my childhood, the Rubik's Cube. The first thing we'll do is take the round horns off the H311 servos and attach them to the pinion gears with the 2mm wood screws. Here they are assembled. Now we put the gripper arms on top of the DS3218 servos. The original gripper arm called for a horn that my servo didn't come with, so I used a remixed version that went directly on the gear. I'll put a link to that in the description. The grippers are on the servos. Now we need to put the DS3218 servos into these slide pieces using some 3mm screws. And here's a tip. These slide pieces are really snug on these servos, and they can be hard to get in because the wire will hit. On my servo, I was able to take it apart and slide the bottom piece off, and then slide it into the printed part. That made things much easier. Be careful though, you don't want to ruin your servo. Here's all the slides assembled. Now we put the 4 racks on the 4 slide. There's a groove in the back of the rack for the servo cable. It takes 6 3mm screws. They go right in here. Now all the racks are installed. Make sure you're using some countersunk screws. Now we'll take the sliders and the arms and we'll fit them together. These can only fit one way. Now with that assembled, you can add your pinion gear to your servo, but you don't need to screw it down just yet because we might have to remove it for calibration. Now we'll assemble the body of the robot. Take all your corner pieces and we're going to press them onto the arm pieces. Now we'll put the legs on and we'll bolt it together. Long bolts on the bottom, short bolts on the top, and the nuts go on front. I did upscale these nuts 2% so they fit a little easier. Now we'll put the rods on the back. I'm going to start with the short rods because that's what they suggest for a 12 megapixel camera, but we might have to adjust these later from some short rods to some long rods. Then on the camera holder, I'm going to start with the longer rods. The camera holder is held on by these half clamps that are bolted with a 3mm screw. Then we'll remove the stand from our webcam. Then we'll put it in the camera mount. The slit is for the cable. This will be held in place by the camera cover. Now it's fully assembled. Now we're going to wire all the servos up to the polluter board. All of my servo wires are too short, and I'm going to have to use extensions for all of them. Different brands of servos are going to have different colored wires. On the 311 servos, black was ground, red is positive, and yellow is my signal. On the 3218 servos, brown is ground, red is positive, and orange is my signal. On the polluter board, the outer pins are ground. I'm going to attach my polluter board to the back of the camera mount with this wood screw. On the servo controller, the 0 channel starts on the same side as the USB mini connector. This is 0, this is 12. This gripper servo will be 0. This slider servo will be 1. This gripper servo will be 2. This slider servo will be 3. We're going to skip 4 and 5. This gripper servo will be 6. This slider servo will be 7. The bottom gripper servo will be 8. And the bottom slider servo will be 9. Now we need power for our polluter board. I'm going to solder this pigtail onto these jumper wires because these jumpers will go onto the polluter board and this one will fit into our adapter. Now we'll plug our power jumper into these last set of pins on the board. The outside one is ground, the middle one is positive. With any luck, we can plug it in, and the board will start working. Now we'll cable up the servo controller board via mini USB to the computer, and we'll start the calibration. Now we'll download the Mastro Servo Control Center. We'll install it. Now we're in the control center. With any luck, it'll already know which board you have, and you'll see all the channel sliders for each servo. Make sure your board is connected. Go over to the Settings tab and select USB Dual Port and hit Apply Settings. Before I start the calibration process, I removed all the grippers and the pinion gears just for safety so nothing will collide. Let's head back to channel settings. On my polluter board, the minimums and maximums were set very low for their values, so I opened them all the way up. I went 496 for all the minimums and 2496 for all the maximums. This allows the full range of movement for the servo. On the gripper servos, for now, set the acceleration to 110. That's 0, 2, 6, and 8. We might need to adjust these later, depending on if the grippers are synchronized or not. Hit Apply Settings. Set the sliders to the away setting. You want the slider to be flush with the arm part. In the polluter Control Center, switch over to the Status tab and enable all the servos. 0, 1, 2, 3, 6, 7, 8, and 9. Now with the slider in the away setting, we'll set the minimum values pretty low. Since this is as far back as the sliders will ever be, we can set these to around 550. This will give us a little room back and forth. Now you can reinstall the pinion gears on the sliders. Now that the pinions are back on for the sliders, we'll move to calibrating the grippers. We'll set the gripper values to their minimum. I recommend around 600 to start on the grippers. Now attach all the grippers to the servos, front to back. That will be the neutral position. Now you want to adjust the gripper servos so the grippers are level. You want them to be as square with the cube as possible. These are the minimums I came up with. Write all your minimums down because you'll need them later for the robot software. Now we need to adjust the gripper arms to the 90-degree position. You'll have to do these one at a time because they will collide. Your grippers will never be in this position at the same time. Set each gripper to 90 degrees and then record the value. As you're setting the maximum and minimum on your grippers from 0 to 90 degrees, remember the grippers should always turn like this. Every servo will be turning counterclockwise. After you have all your 90-degree gripper positions recorded, we'll move on to the far position for the sliders. Set all your grippers to their minimum position, or their neutral position. Place your cube into the grippers. Move your 3 servo down about halfway. Then move your 9 servo up about halfway. You want both sliders to move about the same amount. It doesn't have to be perfect, but try to keep them as equal as possible. You can see both 3 and 9 sliders are around 1300. Record that value. You want the grippers to be snug on the cube, but not super tight. When adjusting the top and bottom sliders, make sure the sliders are adjusted so that the center grippers line up with the center line of the cube. Now bring the 1 servo in, and then the 7 servo in. Again, make sure these grippers are snug on the cube, but not too tight. When adjusting the left and right grippers, make sure the bottom and top grippers line up with the center stripe. When you have the values you're happy with, record all the maximum values for the sliders. Now we need to head on over to the Otvinta site and grab a copy of the robot software. For the setup, we'll be using the Windows version. You do need to contact Otvinta and get a license for the software. You can get a free temporary license for 30 days. Just hit the Contact Us. If you want to buy a license, it's $40 for personal use. Extract your software. You'll now need to install a couple of certificates before you can use the software. Right-click on the certificate and hit Install Certificate. Open. First do Current User, hit Next. Place the certificate in the following store. Select Trusted Root Certificate Authorities. Click Next and then click Finish. Now we'll need to install the cert again. Click Local Machine this time. Click Next. Place certificate in the following store. Trusted Root Certificate Authorities. Next. Finish. Done. Now that the cert is installed, you can install the robot app. Click Install. Now to use the app, you will have to enter your key. Otvinta will email you a key fairly quickly, I've found. Once you have your key, paste it in here and click Save. Now hit the calibration button. You'll need to enter the correct servo channels and the near and far and 0 and 90 degree numbers that we got from the calibration steps. Note that the calibration view is from the front side of the robot. Gripper 0, slider 1, gripper 2, slider 3, gripper 6, slider 7, gripper 8, slider 9. Now enter all the servo number values that you collected during the calibration. You will probably need to adjust these as you tune your cube robot. Now, all the values have been entered, but again, we'll probably need to adjust these as we go. Click Save. Now plug in the webcam on the robot to your USB port. Go to the Configuration button. Select the correct webcam that you just plugged in. You might have a couple. I like to turn on debugging, and I'll show you this in a minute. For now, let's start with the defaults and we'll work from there. Click Save. Now your robot power should be plugged in, your camera's plugged into USB, and your servo controller's plugged into USB. We're ready to start testing the robot. A good first movement is just to hit the camera button. This will just take a quick picture of the cube to let you know if you have the cube positioned correctly. As long as you can see at least part of each of the 9 squares in the picture, you should be good to go for placement. Picture appears out of focus. You can turn the lens on these cameras to adjust the focus a little bit. If the cube appears to be positioned well, then you should be good to go. If not, you can go back and adjust your servo values. My bottom gripper arm probably needs to be moved a little bit counterclockwise. After you've made all your fine configuration adjustments for your servo positions, you want the cube to be pretty firm, but you don't want it to have a death grip on it either. Now you're ready for your first run. Just hit the run button in the GUI, but get ready to stop it in case something bad happens. If you notice one of the grippers turning slower than the other and the grippers are not in sync, go into the pulu software control panel and we'll adjust the channel settings. This is where acceleration comes in. The top gripper arm seems to be spinning a little too slowly, so let's go to 120. And the bottom gripper arm seems to be turning a little fast, so we're going to set this one to 80. Apply the settings. Now we can try another run. On your first run, you're probably going to get an error that looks like this. Since we turned on debug, we can go check out the debug file and see what the camera actually saw. These errors are caused by the camera not being able to tell what color is which. Your robot will see different colors in different light, so be aware of that when you're calibrating. You might want to keep it in the same place. So let's take a look at the debug file. It should be in your default pictures folder. Just pick the largest number. That should be the last run. This shows you what the camera actually saw. You can compare the pictures to the colors on the cube to determine if it's accurately reading the color. You can see in this first example, it saw these 2 blue squares as white. This is usually caused by glare. So the first setting we can try to adjust in configuration is glare threshold. Set it to 1. Hit save. Now we'll do another run to test that setting. And the robot has solved the cube. Now I was able to get the robot to solve the cube with this round camera here in the basement where we have lots of light with only minor adjustments to the configuration. But don't do what I did. Don't immediately open up your cube and mess it all up because you think you're going to have a robot to solve your cube for you. Leave it intact and leave it in the solve position, then you can go through this auto calibration process if you're having problems with the colors being identified by the robot. Place the cube with the white side towards the camera and the red side towards the top into the robot. And then hit run and go through a sequence. Now that you've done the run with the cube completely solved, you can go in and take a look at the debug file. You can see what colors it recognized as what, but you can also scroll all the way to the bottom and you can use these values in your configuration to help you tune your robot to the environment that you're in. So take these values and put them here into the configuration settings. This should hopefully at least get you closer to a configuration where your robot will solve your cube. While making this video, Otvinta changed the camera that they recommend you use with this robot. They're now using this wide version. It helps eliminate the color recognition issues that the little round cameras have. So definitely if you're building this from scratch, go with this one and print the correct mount for that camera. I will be updating my robot soon. And that is the Otvinta 3D printed Rubik's Cube solving robot. It does cost around $250 to get all this together, and it's going to take some filament because there's a lot of printed parts. But man, to watch this thing solve the cube, it's amazing. A few tips. There are great instructions on the Otvinta site on how to put all this together. You do need a good sturdy 6-volt 3-amp power supply. Use the one they link to in the instructions. These servos do take a lot of juice. Also, go with the newer version of the camera. That's the biggest downfall of this robot, is the circle cam and it trying to figure out what color's what. So go with a new wide camera and everything should work out great. Thanks to Otvinta for putting all this together. This project is well worth the small license fee that you collect. If you like this video, please consider giving it a thumbs up or subscribe to my channel. If not, leave your thoughts below. And as always, thanks for watching.